Theodore implements a new strategy game, Defense of a Kingdom. On each level, a player defends the kingdom that is represented by a rectangular grid of cells. The player builds crossbow towers in some cells of the grid. The tower defends all the cells in the same row and the same column. No two towers share a row or a column. The penalty of the position is the number of cells in the largest undefended rectangle. For example, the position shown on the picture has a penalty 12. Help Theodore write a program that calculates the penalty of the given position. Well, this is a fantastic question that is very logical, and there's a lot of opportunities for optimization. I have a link in the description to the question, so if you want to give it a try, go ahead and then join us again so we can compare answers. Otherwise, you can sit tight and enjoy the show. We'll start in 5 seconds. 5, 4, 3, 2, 1. Okay, solution time. So there's two rules that are given. Rule number 1 is that for all y coordinates, the x coordinate of the tower is defended. And for all x coordinates, the y coordinate of the tower is defended. The second rule is that no two towers share the same x coordinate and no two towers share the same y coordinate. And what this tells us is that the x coordinates can be processed independently from the y coordinates, and that saves us from having to calculate the solution in quadratic time. So let's talk strategy. Here's the position of the board state from a top-down view, and they want us to find the largest contiguous undefended region, and that's represented by this green rectangle here. So our first challenge is to detect the borders of any given position. And the way I'm going to do it is I'm going to add a tower to the width +1, height +1 position. And what that lets me do is to treat the border as a defended region. And you might be asking yourself, why not put a border or put a fake tower at the 0, 0 position? After all, the negative x border and the negative y border also needs to be detected. But the reason I'm not going to do that is, well, actually there are two reasons. The first reason is that the width +1, height +1 tower is variable depending on the test case. But the 0, 0 tower will always be in the same place no matter what. The second reason is that the arithmetic involving 0 is very predictable. So for example, x minus 0 is equal to x. We can use these facts to kind of optimize this tower away, essentially. We don't necessarily need it. So we end up with this particular board state, and one thing we should notice is that every defended x position intersects every defended y position, which means all possible rectangles that can be formed from a difference of the delta x and delta y values is on the board, which means the largest contiguous undefended rectangle will have the maximum difference in x values as the width and the maximum difference in height values as the height. So all we need to do is essentially iterate over the delta x's and find the maximum delta x, then iterate over all the delta y's, find the maximum delta y, and the region where the maximum delta x and the maximum delta y intersect will contain our region of interest. And we can narrow it down further by just subtracting 1 from the maximum delta x and the maximum delta y, and that will give us exactly the region that we're looking for. So what does this look like in terms of code? The way I did it was in the main function, I'm essentially getting the number of test cases, and I'm calling a function called solve for each of those test cases. Inside the solve function, the first thing I do is get the width, height, and the number of towers of the board state. Then I instantiate 2 arrays, one for x coordinates and one for y coordinates, with the size n plus 1. That's because we're going to be storing all of our coordinates, all of our tower coordinates in the in the arrays, plus the width plus 1, height plus 1 tower as well. So the issue that we have now is that when we put our coordinates into these arrays, they're put in there in a shuffled order, and we need them from least to greatest so we can get accurate delta measurements. In lots of other places, they use the STL sort method. I used a priority queue because when I found something in the documentation where if you instantiate a priority queue in this way, the C++ essentially uses a method called make heap to build the heap, the minimum heap, and that make heap function operates in linear time. And I thought that was really cool. I have a link in the description to a video that explains why that is. But it doesn't necessarily improve the complexity of the code that I'm showing you. And the reason is, as we continue here, I'm using the pop method, and removing an element from a heap takes log n time. So if you do that for every single element of the array, that's still n log n. So there are a few notable things to notice in this particular loop. The first is that I have two heaps, one for the x coordinates, one for the y coordinates, but I'm only checking if the x coordinate heap is empty. That's because both heaps will have the same number of values in them, which means I don't necessarily have to check whether both of the heaps are empty to get to the accurate solution. The second thing to notice is that the previous x and previous y value start out being the lowest non-zero coordinate. And the reason we're doing that is because the arithmetic behind 0 is very predictable. So the lowest coordinate value minus 0 is still the lowest coordinate value. And we can just sort of leapfrog over that iteration. And the rest of it is pretty standard. I'm essentially looping through all of the coordinates and keeping track of the maximum difference in x coordinates, our MDX, and our maximum difference in y coordinates, that's MDY. And when that's done, I decrement both of those values by 1, and I return the product of MDX and MDY after they've been decremented, which will yield the output, which in this case would be 12. That would be my solution. Thank you for joining me. I encourage you to like, comment, share, and subscribe. Also, if there are any interesting questions that you'd like me to cover, please answer in the comments below, and I would be happy to maybe do a video on those and share that with everyone. Thank you so much. Bye-bye.